Okay, and starting chapter 3, we got 3.1, using exponents. To describe numbers. Make sure you throw the date at the top of your page. I want you to realize that our communication is stronger when we use numbers. And by stronger, I mean it's more specific. It's more clear. It's more focused. I'm not sure if focused has two S's or not. I think it does. But it reduces uncertainty. We say it has less ambiguity. It's less ambiguous. Numbers make our communication more powerful. For example, to say she is tall is not nearly as effective as saying she is 6 foot 2 inches tall. It's what we said in science. The difference between quantitative and qualitative observations. If you can add a number to it to describe the quantity, it's way more powerful, okay, of an observation. Add numbers to it, and you're going to be better. I'm trying to convince you that math is worth working hard at. You know, Cheyenne, it's hard for you to see. If you want to move to that desk in front of Carrie, because you're looking through my shoulder all the time. If you want to move over there. Sometimes we need to do calculations. Sometimes we need to do calculations that do the same thing. That do the same thing over and over. For example, in business, in investing terms and so on, money invested at a 10% return will double every 7 years. Every 7 years, your money is expected to double if you can make a 10% return each year. Okay? So over the years, your money will double. You do this repetitive calculation over again. I'll show you what I mean in a minute. Another example is bacterial populations. In good conditions, will double every hour. Your bodies are full of bacteria. You say human mouth, I think, is like 37 different types of bacteria that frequently grow in it. A lot of people believe a dog's mouth is cleaner than a human's, but that's a myth. A dog has up to like a high 50s types of bacteria that can often be found or growing in their mouth. Okay? Bacteria are all over us. In small amounts, we can be healthy. But when those populations get out of control, we get sick. Okay? A good dentist, good teeth, with low bacteria counts will keep you healthier. So it's important for us to often count bacteria and do calculations in terms of how quickly they're growing. It's a common math situation. So let's develop this money idea a little bit. If you, as a 14-year-old, invest $1,000, you get a job, $10 an hour, you work 100 hours, and you save your money. If you take $1,000 and you invest it at 10%, what investors call ROI, your return on investment. It's a common investing term, ROI. Okay? At a 10% return on investment, how much money will you have at 70 years of age? So by the time you're 70, how much would you have? If you were able to take $1,000 and save it, don't spend it on that bike, on that clothes, on that food. If you just took it and you invested it in an account, that would make you 10%, stock market, whatever. Okay? How much would you have? Well, you could start mapping this out, this repeated calculation thing. Okay? So if you're 14, 7 years later, you're going to be 21. 7 years later, you're going to be 28. 35, right? Every 7 years. And if you started with your $1,000 and you realize that it doubles in 7 years, if you can get 10%, by the time you're 21, in those 7 years, you're going to make $1,000 from your investment. And then 7 more years, it's going to double. And you've just made $2,000 in that 7 years. You've doubled your money. And then you keep investing it wisely at 10%. It doubles again. And by the time you're 35, ooh, you got $8,000. Okay, you've made another $4,000. Your money has made you money based on your investment, and you're at $8,000. And if we keep going, 42 years, this next 7, 49. These are multiples of 7, right? 7 times 7 is 49. 7 times 8 is 56 years. There's another 7. 9 sevens is 63. And 10 sevens is 70. Every 7 years, if you've made a wise investment, world stability, all that stuff, it all stays the same. And you're going to make, when you're 42, you're going to make $16,000. And then it will double, and you're making $32,000. To $64,000 by the time you're 56. $128,000 by the time you're 63. And by the time you're 70, you'll have over $250,000. $256,000. If you keep investing your money at 10% a year, it's called the rule of 7 in the investment world. Every 7 years, 10% is not real hard to get. You got some better years, some poor years. If you can get 10% average over those years, you should be able to take $1,000 now at 14 years old and be worth that. Okay? My neighbor, she's a little bit younger than me. When she was 20, she took out a loan and she bought a couple hundred acres of land behind her dad's farm. It was kind of bush. It felt like the boonies when she was 20. Now she's in her mid-40s. And I don't know what she paid for it back then, but it was only a couple $1,000. And now that's easily worth $250,000. She's made an investment in real estate over 25 years, not nearly from 14 to 70. Somebody would easily pay her $250,000 for that property now. There's road access there. Part of it is cleared. It's a hayfield. You could put a whole ranch on there. Okay? So if you're good with numbers, you're going to be a stronger person in math, in money management. But here in terms of chapter 3, we're looking at repetitive things. This type of stuff is called exponential growth. Okay? So this is called exponential growth. It grows exponentially. The first 7 years you only made 1,000. The next 7 years you made 2,000. The next 7 you made 4,000. And it keeps doubling. That's how much you're going to make each time. Every 7 years you're making a lot more money. Okay? In investment terms, and I believe people who live in South America even use this term, it's called like the snowball effect. The bigger the snowball, the more snow it collects. You push a little snowball and it takes a while before the thing starts getting big. But once it gets big, it really picks up snow fast. And pretty soon it's so big you can't push it anymore. Like a snowball grows exponentially. A small snowball starts slow. But as it gets bigger and bigger, much faster than it did at the beginning. Just like this money. This is called exponential growth. We want to figure out exponents. This exponent language, this exponent trick in chapter 3. It should make you a stronger person. Financially, we want our money to grow exponentially. If you can understand that, make some wiser investments, use your math skills to do that. Okay? We talked about using math as numbers. To say something like, he is rich. Rich is like qualitative. You're rich. You've got a quality of richness. But how rich are you? Okay? How much money would it take? Do you have to be a pro athlete making thousands of dollars a minute while you're competing on the court or on the ice? Okay? Whereas if you would say, he is making $5.2 million a year in his contract. Okay? Yeah, that's nothing special. Okay? It's pretty good. Most of them, I would say, don't make that, but there's lots of them who do. So, as soon as you add a number to your statement, it right away clarifies it, because richness is a real random kind of thing. Okay? What does it mean? So, How do exponents work? So how do exponents work? You need to realize they're a shortcut. One of the goals of 3.1 is to realize that exponents are a shortcut to repeated multiplication. Okay? They're a shortcut to repeated steps. Once you understand the shortcut, we will you'll never go back to the long process of repeated multiplication. So if you learn the rules of this shortcut well, if you learn the shortcut, you won't get lost. That's my fear as your teacher. To show you this shortcut, some of you are going to make mistakes. We want to try to learn this trick without making the mistakes. Otherwise, you better stay doing the long system. Okay? You realize that three plus 3 plus 3 plus 3 is just like saying, hey, we've got 4 3s. So 4 3s is 12. Multiplication is a shortcut for repeat addition. Multiplication is a shortcut for repeat addition. If you realize that 4 3s is 12, rather than 3 plus 3 plus 3 plus 3, you can just say 4 times 3, and you got your 12, rather than going the long way. Most of you who have learned the multiplication table don't want to go back to adding up all these repeated parts. We would much sooner go 7 times 8 is 56, rather than going 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8. And add those all up to get to 56. We got real sick of doing repeat addition, so we just use multiplication. Okay? But some of you are messed up by multiplication. You still got to go to a calculator. You still never learned that quick. So it's not much of a shortcut. But those are math skills. We hope to build them. Okay? In exponents, we want to have a look at all these rules so it makes sense to you. Okay? So, a power is made of 2 parts. a base and an exponent. Actually, I want to use a different color here. So it's a base and an exponent. So power has a base, it's a coefficient. For example, 4 to the power of 3. The 3 is the exponent, the 4 is the base. All together, this is called a power. Okay, so learn that language. So as we refer to it, you'll be able to keep it straight. This means 4 is multiplied by itself three times. Okay, 4 is multiplied by itself 3 times. So it's like 4 times 4 times 4. Okay, so it's a shortcut for repeated multiplication. And 4 times 4 is 16. 16 times 4. 4 fours is 16. 4 times 4 is 16 times 4 is 64. Okay. We could write that cubed equals 64. The value of that is 64. Could you guys pull out your calculators? You all have a different system, probably. Your calculators have a different system. Would you be able to punch in this power using your different buttons and get 64? Okay, if you would flip in your textbook to page 94. Please look on page 94 there. We're going to look at example number 2 on page 94. They want you to, in your brain, to come up with some models. Use some models to represent common powers. And one of them is this idea of squared. When you square something, you say 4 squared or something. The model that should, a little mental picture that should show up in your brain is take a square and divide it into 4 units by 4 units. And when you're finding the area of this, for example, you would go base times height. And so you would go 4 times 4, or 4 squared. And you'd report that in your answer as 16 of these units squared. It's a way to talk about surface area. Okay, so we're talking about surface area. Here for that, and you use the word squared for that. Another word is cubed. And it's good if you would come up with a picture in your brain of a little cube. So you have this little picture of a cube, and the volume is base times height times width. Sometimes called length times width times height. And it would be 2 units times 2 units times 2 units, or 2 cubed. And it'd be 8 units to the power of 3, or we often say 8 units cubed, is the volume of this, okay? In construction, we use squared and cubed a lot. You order concrete by the cubic meter. You buy paints and plywood stuff to cover a certain surface area of wall or roof or so on. So we talk about these skills, very, very common in construction. Example number 3 on page 95 talks about integer bases. And integers, in this case, we're going to use negative bases. For example, if we had -2 cubed, we could also write it -2 in brackets cubed. Actually, let me change this to the 4th, and I'll change this to the 4th. Before we break for lunch, I want to make sure you get this example written down. Here, we take -2 times -2 times -2 times -2. And if this is even, the number of negatives times negatives is an even number, your answer will be positive. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So your answer here is positive 16. If you've got an even number of negatives multiplied by themselves, the final answer will be positive. If this is not in brackets, though, a helpful way to look at it is like this. It's like -1 times 2 to the power of 4. In the order of operation, you need to get rid of the exponents before you multiply. And so really this becomes -1 times 2 to the power of 4 is 16. Your answer, when it's written this way, is actually -16. So make sure you know that difference. And if you can figure out this little -1 trick, it will save you a lot of mistakes in math from here on in. A negative number is like -1 times that number. If you could visualize it that way, it might help you understand this.
Here's the afternoon's announcement.
So for some practice problems to put this information into play, there's a section at the beginning that asks, can you verbalize? This knowledge. You'll feel like you're in English class a little bit, and you should work on questions 1 to 3 on page 96. Have you got exponent skills? You should work on questions 4 to 13 on page 97. Can you apply these skills to solve lifelike problems. You should work on questions 14 to 21. And if you can extend, take this information to a higher level, then you should work on questions 22 to 23. This is your homework. The more of these sections that you can complete, then I will let you be assessed at that level. You need to complete your homework before I will let you write a quiz. So please do this homework. Keep up. If you can get right through the extend questions and shoot for an A grade going beyond expectations, then you need to complete all the way through question 23, and then I can come up with some questions that will quiz you on that. So if you can do the skill level questions, that's for a C. If you can do through the apply questions, you can put that to work to get a higher mark with a B. And if you can take that beyond expectations and do the extend questions, you can get an A. So that's kind of how the assignments will be structured from the different levels.